Hello everyone and welcome to your walkthrough for worksheets 6B, 6C, and 6D for the college algebra course. This is week 11. I'm going to do something new. I'm going to do all three worksheets in one video just because all three of these go together, and I'm just trying to save some time with making these videos. Okay, so what we're looking at with these worksheets is we're graphing rational functions and kind of all the little nuances that go into that. So like little tricks and stuff that you need to figure out. We're also going to be talking about direct and inverse variation. And I'll explain that when we get to it. And then we're also going to be talking about just solving some inequalities at the end, so we'll toss that in there as well. So first worksheet that I want to talk about is worksheet B. So this is 6B, or rational functions B. Let's look at number 1. Okay, so on number 1, you have on top it's going to ultimately be a degree 3, and on the bottom it's ultimately going to be a degree 3, because if you multiply that x squared times that other x, you'll end up getting x cubed, and same thing on the bottom. So the first thing you got to do on this problem is you got to factor out everything into its little bits, or into all of its factors, so that you can see if something cancels, because if something cancels, that will lead to some other stuff, and I'll show you what I mean. So x squared minus 9 is going to factor into x plus 3 and x minus 3. Similarly, on the bottom, x squared minus 4 is going to factor into x minus 2, x plus 2. So if I write this over here on the right, you notice that x plus 3 is on top and bottom, so we cancel those in red. And then we cancel the x plus 2 on top and bottom, and that's in blue. Now, if this happens, what you have to do is you have to figure out what would have made that 0, because that's a number that it can't be, because ultimately you would get 0 on the bottom of your fraction if you had that. So for the blue one, I said x can't be negative 2, and for the red one I said x couldn't be negative 3, because that's what would make those 0. So then you plug those into whatever's left over. So whatever's left over is x minus 3 divided by x minus 2. For the blue one I got 5/4 for y, and for the red one I got 6/5. So what that's going to be is those coordinates negative 2 comma 5/4 and negative 3 comma 6/5. That's going to be a hole. And the reason it's a hole is because your graph at those particular points is going to end up being divided by 0. So that's why they don't work. So that's why we have to include that. So I used red and blue for both of those on my graph as well. And I just put an open dot. Okay, so we just take what's left over. So we say f of x equals x minus 3 over x minus 2, and it's going to be business as usual from here on out. We have a vertical asymptote at x equals 2, because that's what makes the bottom of this 0. I have a horizontal asymptote. Since the degree of the bottom and the top match, we look at the coefficients, and they're both 1, so 1 divided by 1 is 1. So we're going to say our horizontal asymptote is at y equals 1. And then our y-intercept, well, you plug in 0 for your x's, and you get negative 3 over negative 2, which reduces to 1.5. So that's going to cross the y-axis at 1.5, so I put that dot on my graph. And then my x-intercept, I just say, well, what makes the top of this 0, which is 3. So 3 minus 3 would be 0. So that's where it's going to cross the x-axis. So I take all of this information, I put it on my graph, I put my asymptotes and my intercepts, and I put my 2 holes, and this is the graph you should end up with. Okay, let's talk about something new. Let's skip down to number 3. So for number 3, I looked at the top of this and I said, oh, I wonder if that's factorable. So I tried to factor it. It doesn't factor, because there's nothing that multiplies to make a negative 4 that adds up to a negative 5. It's just not possible. So I just keep going. So the vertical asymptote is what makes the bottom 0, so that's going to be 2, so x equals 2. On this one, real interesting, the degree of the top is 2, the degree of the bottom is 1. So that means there is no horizontal asymptote at all. There's actually going to be an oblique asymptote, and I'll show you what that means. So for the oblique asymptote, to figure out what that is we're going to divide the top of this by the k from the bottom. So thinking back to the last chapter when we did synthetic division, the k for this would be whatever makes the bottom 0, which is 2, so that goes out front. And then I just put the coefficients, so 2, -5, and -2. Now you divide this, you end up with 2, -1, and -4. -4 is your remainder. We ignore that remainder. We just ignore it. So I put it in a box and I said, okay. Then the 2x minus 1, which was left over, is what I say y equals. So y equals 2x minus 1. Well, that line is our oblique asymptote. So we go down 1, put a dot, and then go up 2 over 1, up 2 over 1, up 2 over 1. So you get a diagonal line on your graph. And oblique just means kind of diagonal, I guess, in this situation. So I have a vertical asymptote and oblique asymptote. So I find my y-intercept. Y-intercept is what happens when you plug in zeros for x's. So you get -2 over -2, and that equals 1. So it's going to cross the y-axis at +1. And then my x-intercept, well, it's just what makes the top of this 0. Well, the top of it we said was not factorable, so this is going to be kind of hard to find. So I used quadratic formula. I plugged them all in, and blah, 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 blah. I got 5 plus or minus the square root of 41 divided by 4. Well, I wanted to actually have a number, so I found out what the decimals were. Well, I got 2.85, and I put that on my graph, and I got -0.35, and I put that on my graph. Well, find a couple more points if you want. You could use a table in the graph, however you wanted to do it, but you end up getting this line on the left and this line on the right, and that's what it ends up looking like, okay? All right, so that is it for worksheet 6B. The rest of those are pretty straightforward using some of the same tricks that we just used, okay? So then let's talk about worksheet 6C. This one's talking about direct and indirect variation. This is basically what it is. If they're saying something is direct variation, that means it's going to be multiplication. If they say it's indirect, it means it's going to have division. And that's really all you have to know. The K is what we're going to be solving for in these equations, so I'll show you what that looks like. So let's skip down to number 4. So it says, if y varies directly as x, so we know for that one we're going to have y and x, and it's going to basically be this equation right here. So then they say when y is 20 and x equals 4. So we plug those in, we get 20 equals 4 times k, and we're going to solve for k. K is just a constant, and that's what we're going to be using for the rest of the problem. So divide both sides by 4 and we get k equals 5. Well, I rewrite my original equation now with k equaling 5 because we just found that. So then it says, okay, tell us what y is when x equals -6. So I just rewrite this equation with my k replaced with a 5. I plug in -6, multiply those, and you get y equals -30. That's it. Okay, real similar for inverse variation. So let's look at number 5. It says y varies inversely as x. So we just write y equals k divided by x. They say, okay, this is your situation. Y equals 1 negative. I called that -1. And x equals 3. So I plug in 3 for x, -1 for y. Solve for my k, you get k equals -3. So then I rewrite the equation as y equals -3 divided by x. And this is our standard equation now. So then it says find y when x equals 20. So I plug in 20 for x. You divide -3 by 20, you get -0.15 or 0.15. And that is your final answer. Okay. Those first ones are pretty easy. Obviously they're going to ramp it up. So let's look at number 7. So this one says, let A be directly proportional to m and n squared. So what that means is it varies directly. So we're going to have A equals k times n times m times n squared. So that's how I get the stuff in black. Then it goes on to say, and inversely proportional to y cubed. So that means we're just going to divide all that stuff we just wrote by y cubed. And this is what we get. Then they give you a situation where a equals 9, m equals 4, n equals 9, and y equals 3. So we're going to solve for k using all those numbers. Well, if you plug them all in, do your division, bring everything to the other side, you end up with k equals 3/4. So I rewrite my original equation, but now k is 3/4. So then they say, well, figure out a if m equals 6, n equals 2, and y equals 5. So I plug those in for all those variables. You end up with After doing all this on a calculator, 18 divided by 125, and that is our final answer. Okay, the last one I'm going to talk about on this worksheet is 13. It says the period of a pendulum varies directly as the square roots of length L of the pendulum and inversely to the square root of acceleration due to gravity. Well, directly means k times the square root of L, and then the inversely means divided by the square root of A. So this is how I get the equation for this. So then they give you a situation. It says find the period when the length is 121. So the square root of that's going to be 11, and the acceleration due to gravity is 980 if the period is 6 pi. Oh, okay, so they give it to you backwards, and this is confusing. So they tell you the situation that works down at the bottom, and then they go backwards. So basically, 6 pi equals k times the square root of 289 divided by the square root of 980. Well, if you plug this into a calculator, do all the division, move everything to one side, you find out that k eventually equals 34.71, and it's about equal to that. I chopped some stuff off there. So then it says, okay, figure out what the period is when you got 121 for the length and acceleration due to gravity is still 980. So you plug that in with your new k, and you end up with the period being about 12.2. And I guess that's in seconds because that's what it was before. So I didn't write my units there. I should have, but it's 12.2 seconds. All right, last worksheet. Let's talk about 6D. So 6D, what you're doing for these is you're going to solve for x, and it's going to be, these are inequalities, so we're going to have a region of answers or a whole bunch of answers that work. So let's look at number 1 real quick. For this one, both of these have a 2 in them. Both of them have an x squared in them, so that's why I pulled out a 2x squared, and this is what you get. So from here, we're going to have 2 different answers. Well, what makes that 2x squared out front 0? Well, that will be when x equals 0. And then what makes 2x minus 3 0? Well, that's going to be, I set that equal to 0, and I solve, and you end up with x is 3 halves, or 1.5. So what you got to do is you got to put these on a number line. And since there's no equality, these are going to be open dots. So that's put an open dot at 0 and an open dot at 1.5. And then you have basically your number lines cut up into 3 regions. The far left stuff, in between the 2 numbers, and the far right stuff. From here, you have to test each region to figure out where your answers are. So I plugged in a number that was really, really negative, and you end up with an answer that's negative, and that's less than 0. So I said that works. In between these 2 numbers, I plugged in a 1, and you end up getting 4 minus 6, which is negative 2, which is less than 0, so that's good. So I said that region works. And then last, I tested a really big number, a number that's bigger than 1.5. So I tested like 10, and you end up with a gigantic number minus a not so big number, and it ends up being positive, and that is not less than 0, so the far right region doesn't work. So what you say here is your answers are negative infinity all the way up to that 0, and they're in between 0 and 3 halves. And I use soft brackets on those instead of the hard brackets because nothing is included because there's no equality here, and that's how I get my answer. Okay. Let's look at number 2. So for number 2, at the very beginning of this problem, we have some division. So we got to figure out what x cannot equal. Well, x cannot equal 0 because if it is, you'd have 1 divided by 0, and that would screw everything up. So that's one of my critical values. So over here on the left, I solve, or I can turn x into a fraction, and I combine these, and you end up with 1 minus x squared is greater than 0. Subtract 1 from both sides. You end up with, at the end of the day, you end up with x equals, or x is not equal, x is less than plus or minus 1. Okay, so I put the plus or minus 1 on my graph. I put the x can equal 0 on my graph. Everything has an open dot because there's no equality going on here. And so our number line is cut up into 4 regions. Well, I tested a number less than 1, it didn't work. I tested a number in between -1 and 0, it didn't work. I tested a number between 0 and 1. It did work. And I tested a number bigger than 1. It did not work. So your only answers, the only things that make this work are the numbers in between 0 and 1. So for that, what I'm going to say is just my answers are in between 0 and 1. Okay, let's look at number 5. So number 5, we have fraction equals fraction. Well, not equals. A fraction is bigger than another fraction. So what we're going to do is we're going to do some cross multiplication. There is a little trick to it to keeping the inequality going the right direction, and that's to keep the bottoms in the same spot. So I did 1 times x plus 5, and I kept it on the left here in blue. For the other one, I did 4 times 2x plus 3, and I kept it on the right, and that's in red here. So solve this up, and you end up getting x is less than -1. And so I put that on my number line with an open dot because there's no equality. And at the very beginning, the two things that would have screwed up these two fractions would have been -5 and -3/2. So those are my other critical values, so I put those on my graph. So I end up doing this, and you end up getting, I test each of the regions, and we have 1, 2, 3, 4 different regions to test. So I end up getting answers in between -5 and -3/2, and from -1 to positive infinity. So those are my answers. All right, last one. Let's look at number 8. So number 8, at the very beginning of the problem, I say x can equal 1, x cannot equal -1, because that would make everything 0 and screw it all up. So then I got to combine these fractions, so I made a common denominator. You end up getting this. Move the x squared minus 1 over the other side, solve. And it ultimately factors, so we end up getting x is -2/3 and x equals 3. So those are my other critical values. Well, nothing has equality, so everything's an open dot. So I put on those 4 critical values on this number chart. I test all of the regions, and these are the ones that worked. So we say -infinity to -1, and -2/3 to 1, and 3 to infinity. And that is our final answer. Okay, so that was worksheets 6A, 6B, and 6D. So that is everything for this week. Should you have any questions, feel free to bring those to class, or you can email me, or you can find me like outside of class if you wanted to. Okay. I guess the main things for this chapter are graphing the rational functions, and a bit of inequalities, and then just inversely and directly proportional, which is kind of easy if you're able to do that worksheet. So like I said, give it a try, and if you get stuck, let me know. Okay, that is it. Have a lovely day, and ask me if you have any questions. All right, talk to you later.